Hello everyone. This week we're going to begin with Chapter 3. What do interest rates mean and what is their role in valuation? And in the book there are 4 or 5 examples that I just want to go over today. And those include a simple loan, a fixed payment loan, a coupon bond, a discount bond, and an example on rate of return. Some of this might be review, but we can knock some rust off here. And also, I think prior iterations of this class required a financial calculator, but you actually don't need that. You can use Excel. And I think once you get into the labor market, most businesses use Excel anyway, so it might just be helpful to learn it that way. Okay, to begin with, we'll start with the simple loan example. And this is obviously related to time value of money, present value. I'm sure you all have seen stuff like that before. So, example 1, if Pete borrows $100 from his sister, in 2 years she wants $144 back from him. What is the yield to maturity? I changed this question a little bit from what was in the book, just to show you more clearly. So I'll do this by hand to begin with, just to show you what's going on here. The functions in Excel obviously do it for you, but I think it might be useful to actually see what's going on. Okay, so the top, again, I'm sure you've all seen this first formula up here. It's just a simple time value of money. In the book, they rewrite it like this. Same exact thing, it's just little algebra. So Pete gets 100 today, so that's the present value. And he owes his sister 144 in 2 years. And we are asked to find the yield to maturity, which is I, and N, 2 years. So the first thing, we can multiply by the denominator there. And then we need to move that exponent over, and to do that, you multiply the exponent by the reciprocal. For example, if I wanted to find x here, I would take x squared to the 1/2 power. And then, of course, I have to do that to 100 as well. So then I get x to the 1, which that, a lot of times they don't even show that, but that's what it is, equals the square root of 100. That's what the exponent to the half there means, equals 10. So that's the logic. So up here, we want to get rid of that 2 right there. So we take 100 to the 1/2, 1 plus I to the 2 to the 1 times 1/2, which that cancels out to 1, equals 144 to the 1/2. So the square root of the square root of 100, which is the same thing as 100 to the exponent 1/2, equals 10. And then the 2 times 1/2 to the 1, which that just disappears. And then 144, square root of 144 is 12. As you can see, I made this easy on myself. Then we divide that over. And then lastly, we just have to subtract 1 here. Minus 1, or to make it easy, 10 over 10, which equals 1, equals 2 over 10, which equals 20%. So again, simple example. But it may be useful for you to see because the book gives it to you in formulas, so maybe it's helpful for some of you to see that. Now I'll do the same thing in Excel. And by the way, I included these formulas here on the right. I think they might be slightly different, like abbreviations on if you have a financial calculator, but it's the same thing. So present value, we have 100. Future value, 144. And also, just like the financial calculators, if you are calculating N or I, you have to make sure either present value or future value is negative, or if you're working with a payment, maybe the payment is negative. I think it's helpful, obviously, to think about the problem if you repeat here. So you get $100 today and you owe it in the future. So I usually put negative for the future value here. N is 2. And from the right here, we can see that rate is what we're looking for, which is the yield to maturity or the interest rate. And Excel tells you here which arguments that it's asking for. So N per is N, number of periods. Payment, in this case, is 0. He pays it all back at the end in one lump sum. Present value is 100. And I'm just putting this in cell so you all can see it, but you could, within the rate function, you could just type the numeric. So you can do it either way. And what's nice about Excel too, you can build templates like this and save them, and you can use them for quizzes or tests or anything like that. Or if you have a job, you can do that too. Future value 144, and there's the 20% that I just calculated by hand. And just a quick preview, maybe you've all seen this before, but maybe some of you haven't. So I'll work this problem in another way with a different function. So we'll assume we know it's 20%. So of course, the question could be phrased slightly differently and ask you about the future value, the present value, or the number of periods. So we'll just find the future value here. Assume this is blank. Again, if you look at the right here, the function we want is FV. Fill in all the required arguments. Payment again is 0. Present value 100. And there's the 144. So you can work it any way you want. I won't do it for present value. I think you all get the point. You don't see this one as often, but you can also do the number of periods. So suppose that you want to buy a car and you know you can afford $300 a month and you want to know how long it's going to take you to pay it off. So here you can use the N per argument and do the same thing. Okay, so that's simple loan. Again, this is a lot of probably review. So we'll move to a fixed payment loan. So this is more of, I know I just used the car example, but I didn't include a payment in this problem. It's just assumed in a lump sum. Here, the fixed payment loan would be more like what you'd see in real life if you bought a house where you make a monthly payment. You don't just pay it all off at the end. Okay, so you decide to purchase a new home and you need $100,000. The bank offers you the loan with a 7% interest payment. What is the yearly payment if you plan to pay it back in 20 years? So the present value, you get the $100,000 this year or today. Future value is 0 because you'll have to pay the entire thing off. N is 20 years. 7 is the interest rate they're charging you. And we want to know the payment. So the PMT function. And see here, since I'm calculating the payment and I'm not calculating the interest, it knows that it shows you here that it's negative because that's what you're paying. And this is not in the book. I just wanted to show you all this. So just to calculate the total you would pay is obviously what you would pay each year times the number of years, 188,000. So you're paying 88,000, almost 89,000 in interest over 20 years when you only took out 100,000. So let's assume we do it monthly. which is what mortgages actually are. The present value and the future value are the same. For N here, since there's obviously 12 months in a year, 20 years, the number of payments is 12 times 20, 240 months. And the interest here, obviously this is in terms of months now, so it's not 7% a month, this is yearly. So we'll take this and divide by 12. Same thing here, payment function. So you're paying $775 a month. Now let's see what you pay total. So it's this monthly payment times the 240 months. You pay $186,000, so you actually pay less. And the way that's working is because you're effectively giving the interest less time to accumulate. Here in the book, they give you this formula. So essentially, each one of these payments is a simple loan, as we did in the first example. And it depends what period it is, where this is in the first period, this would be the second period, all the way up to N periods, or in this case, 240 months. That's what's going on behind the scenes. So the moral of the story here is the more often you pay, actually, the better in this case. Okay, moving on to the next is a coupon bond. Find the price of a 10% coupon bond with a face value of $1,000 and a 12.25% yield to maturity and 8 years to maturity. So some people can get confused, I think, because there's 10% and 12.25%. So it's like, oh, are there two interest rates? What's going on here? So the coupon, when it says 10% coupon bond, that means the coupon rate is 10%. So the 10% you use to calculate the payment. So you can think of a coupon bond as a fixed payment loan, except you're on the other side of the transaction. So you are kind of being the lender. So for example, a corporate bond, Procter & Gamble might issue bonds because they want to raise money to do something, and you buy one. So they're making payments to you rather than the other way around if you loaned from a bank. But there's only one slight difference. It looks just like the fixed payment loan because it's a series of payments that are each discounted in each period. But then at the end here, they give you back the face value. So you get your $1,000 back here. And the yield to maturity is effectively the discount rate because it's in the denominator. So that's you can think of that sort of as it's going to get bigger and bigger as time goes on because money today is worth more in the future. You could be earning a return. Okay, so the present value that's what we're trying to find, sorry. So find the price, that's what we're trying to find right now. The future value is like what I just showed you there in orange at the end. That's what you get back in 8 years. So N is 8. Your yield to maturity, what I just showed you in the denominator there, that's 12.25. And the payment, that's where the coupon rate comes in, 10%. So the coupon payment is just simply the face value times the coupon rate, which is 10%. So there's your 1,000 times 0.1 or 10%. So you get $100 each. That's what's going on here. You get $100 each period. And as you can see, again, since the yield to maturity is in the denominator, the present value of each one of those is less and less and less because it's discounted more heavily. So again, we want the PV function. And again, Excel's going to give it to you negative because this is what you would have to pay today, $889, or that's what it's worth today. As you can see, as this goes up, it's going to get cheaper and cheaper because that's what it's getting discounted as. Or if it's low and you can't earn an otherwise higher return, you're gonna have to pay more for it. Okay. Now a discount bond. This is actually more simple than a coupon bond. You can think of it as it's just sort of like a simple loan, except again, you can think of it as you're on the other side of a transaction. So it's really just a simple growth rate or rate of return. So the example they give in the book is you spend $900 on a bond with a face value of $1,000 to be paid in 1 year, and you calculate it. So the present value is negative 900 because you spend that today. Future value is 1,000. 1 year. This one is super simple. There is no payment. And it's going to be 11.11%. And again, this is the same thing as so that's the same thing. It's just a simple growth rate or rate of return. Now for a little bit more complicated rate of return, this will be our last example. Where am I? Here we go. What would the rate of return be on a bond bought for $1,000 and sold 1 year later for $800? The bond has a face value of 1,000, a coupon rate of 8%. So again, we'll do this one by hand. So that's the way it is in the book. So in this one, there's two separate aspects here, which is the payment, or they call it C, but I just like to keep the same notation that is on the financial calculator or the function in Excel. But that's just like the coupon. Again, that's from over here. In this case, they call it the coupon because you're the one getting the payment. So R is what we're trying to find. In the first one, it said 8% on $1,000. So again, to find that, I'm doing this payment there, is 80. Plus, and this T minus 1 subscript here, that just means in the future. And just if it's T, that means today. So if they showed PT minus 1, that's last year's or last period. If it was PT plus 5, that'll be the price in 5 years or 5 months, whatever the periods are. So actually it said that you bought it for 1,000 and then sold it, which would be this next period, T plus 1, for 800. And then you bought it in time T at 1,000. So you actually took a loss there. And again, the PT is in the denominator, what you paid for it, which is 1,000. Oh, I'm sorry, minus, not plus, because that's what you paid. So you have 880 minus 1,000 is negative 120 over 1,000 equals 12%. That's all I have for you for now. If you find other examples in the book that you want me to go over, let me know. And if you have any questions about Excel, let me know.